Today's presentation is about Picoportal, a user-friendly software application to improve systematic review screening process functionality and expedite transforming research into decision-ready evidence. Hello, my name is Eitan Agai, and I'm the founder of Picoportal. And today I will use a case study by Dr. Mary Butler from Minnesota University. Looking at your website, there was a quote from Steve Goodman that says, no matter how many randomized clinical trials have been done on a particular topic, about half the clinical trial cite none or only one of them. As cynical as I am about such things, I didn't realize that the situation was this bad. Very interesting quote, and EBR responded by saying, no new study without prior systematic review of existing evidence and efficient production, updating and disseminating as systematic reviews. Now, in my opinion, researchers know what a good research is, but it is too hard and it becomes harder to sift through all the studies. So how do we mitigate that? In order for me to illustrate it, let me share with you a little bit about my background, which is relevant to this discussion. It is not a typical, I'm not a typical presenter to this audience. My experience is in the financial technology, or specifically in the mortgage industry here in the United States. I lectured in AI automation at the Mortgage Banking Conference, Deloitte & Touche University, and featured on the National Mortgage News. The mortgage industry is worth trillions in the United States, and my clients typically ranges between 2 billion and 36 billion. So armed with this experience of servicing those clients, I developed Picoportal during the pandemic to transform research finding into decision ready with ease. How did I do that? Well, it turns out that once Picoportal was born, it immediately got the world's attention. And since September of 2020, there was some sort of an explosion where over 180 institutions, 800, close to 1 million citations from 70 different countries use Picoportal so far, and the list continued to grow on a regular basis, as you can see from the map. To eliminate waste, we need to narrow the citation search. So when someone searches a bibliographic database, the search do not identify the eligible citations for your study. It is like if the Chihuahua in this picture is include and the muffin is exclude, the search will return both. And why? Because it's a hard problem to filter the right citation, and it requires manual intervention, intensive manual intervention, in order for someone to figure out what meets the eligibility criteria. So in a traditional screening, if we look at the Prisma above that has about 10,896 citations, and even though there were 3,600 duplicates that were identified, still someone needs to go over 7,295 citation. The screening itself is done in a random order, as you can see here, where the red dots represent exclude and the green dot represent includes, and it's throughout the project timeline. That, of course, in many cases, also resources need to be allocated manually. It's not a one person's job. I mean, typically there's 3 or 4 and sometimes 10 people working on screening those citations. So someone needs to allocate the resources. And in many cases, when it's done in a traditional way, it's a sequential process. And by doing it sequentially, you're extending the timeline of the project itself. Now, also when I review the different tools that are available, most open source commercial tools are, in my opinion, glorified spreadsheets with some logic in them. So that is not going to help to reduce waste. So how do we do that? How do we mitigate this issue? Well, one way to do that is looking at the same problem is to apply, for example, a prediction method where the citations are sorted by the most likely eligible first, right? So as you can see here, there are more green at the beginning and more reds toward the end of the timeline. Now, when the user screen those citations, they can actually confirm that there's more includes at the beginning and many more excludes toward the end of the project. And somewhere around, there is a golden bar where the user can make a choice how they can reduce the resources. For example, moving from dual review into a single review, or skipping the review altogether if they feel that the amount of includes that they will find is negligible compared to the body of articles that are eligible. So looking at Picoportal and one of the projects that were done by the National Academy of Science, which is a guidance of fast testing and health outcome, you can see that there were about 5,172 citations. The system automatically eliminated 112 as duplicates. There was a team of 18 researchers, and it was a dual review. Now here at the beginning, you can see that the articles were screened in a random way. Many exclude, as you can see by the red dots, and a few includes in between. Then once the machine gathered enough information, Picoportal started to sort the article by the most likely include first. And as you can see here, in the second part, there's many more includes and very few excludes. And then later on, as the project progresses, there are many more excludes and very few includes. And somewhere around here, there is a golden bar where the user can say, we have enough information and we don't need to continue. And by that, eliminating the waste by reducing the amount of manual effort that it's required. To reduce weight and increase efficiency, we also need to minimize the learning curve. Picoportal offers an intuitive way to review the citation. As one can see on the top, there are a very clear title, author, publication date, a very familiar look for anyone that reviews citation. On the bottom, one can see the abstract of that particular citation, and you can also see the color-coded information. For example, the yellow color code over here indicates the population, so it's critically ill ventilated patients, for example, as population. And also the intervention, as you can see here, that's in purple. And even the study type, like randomized control trial. All of these informations are being generated automatically using natural language processing and help the reviewer make a choice much faster. Specifically, if it's an excluded citation, they can move very quickly through that. Also, the user interface or the user experience is quite intuitive, where information is being offered right on the screen for population, intervention, outcome, etc., or they can make an exclude reason using a drop-down list, and use also shortcut keys, so they don't have to use the mouse. Article analysis give a bit of an insight to the user of what's inside those articles. And the user can also tag the articles, basically creating order from a messy type of data that they receive, and also write some notes. When managing a project, one can deal with very large amount of citation. In this case, it's 11,466, as you can see, but also with a very large group of people. In this case, you have 6 members. And the idea here is how to optimize the project to expedite the completion. So Picoportal uses Crowd Engine, which automatically assign jobs based on the user experience and their role within the project. So once they log in, information is available for them to cite. Once they log out, this information is being released and it's ready for someone else. And based on the workflow, the system automatically will know whether or not the citation require 1, 2, or more reviewers to decide its eligibility. Generally speaking, you know, the platform itself, it's a high performance evidence synthesis. And the reason is that it basically takes the user through the entire experience from uploading the search result through deduplication, screening citation, full text review, quality assessment, data extraction, and then exporting it to a very familiar and common file formats. Now, how does it do that? First of all, by deploying technology, right, and automation. So that we mentioned the Crowd Engine that automatically assign users. So that reduced the work for anyone that managed the project. There's a very strong deduplication with advanced UI that let you verify that what was duplicated is an actual duplication. The system used natural language processing to automatically highlight keywords and key phrases. It uses machine learning to predict the most eligible citation first. It automatically will scan the web and identify open source PDF file, download them, and when possible, upload them so it will minimize the work for you, and even on PDF files that are inside the firewall. It's mobile device friendly, so you can screen on the go. And it provides for project manager both user analytics and Prisma. It also offers an agile setting for the project so that the project manager can change the direction of the project in midstream if they need to and move from a dual review into a single review. It supports dual review, let's say, with a principal reviewer. So if you have 1 or 2 individuals within your team that are considered as expert and you would like them to review each citation, you can do that as well. Of course, there is tagging while screening and data extraction and quality. One of the case studies that I chose is a case study that was done by Dr. Mary Butler from University of Minnesota. It was done for the National Cancer Institute on Pediatric Oncology of Systematic Review. The study had 12,186 citations, and the system automatically found 4,197 duplicates. It had a team of 9 researchers, and they used dual review to review each citation. They used Picoportal to simultaneously screen and build an evidence mapping by using the tagging function. This is the case study project dashboard on Picoportal. As you can see, there are 12,186 imports, 4,197 duplicates that were identified by the system, and 9 team members. Picoportal also offers user analytics and project analytics for each project. So in this case, the project lead can get insight into the user and the reviewer's performance. So one can see on the top left how many users and how many citations they reviewed and what's their review rate of include versus exclude. On the top right, they can see the accuracy per user. At the bottom left, one can see the time that was spent by each user, and the bottom right, the speed where how many citations or full text review were performed. Here again, one can see the full review screen with the embedded PDF, and the user can choose on the top right, as you can see, whether the article should be included or excluded using PICOs, or if they would like to eliminate PICOs, they can use their own reason. You can also see the full text review that requires 2 reviewers. One said yes, the other one said to exclude based on intervention, and the final consensus was by Mary Butler as an include. Also, you can see that the article itself was tagged while being reviewed, and that eventually served as creating some order from the original messy data. The end result is this output. So the output is a spreadsheet where one can see the citation information such as title, first author, publication year, and journal, and also the tagged citation and full text. In this case, you can see the target population, the condition, the study design. And of course, you can also filter with the built-in filter in the Excel spreadsheet, for example, to filter for all the patients that has a sickle cell disease, for example, and get those citations and articles that meet those two conditions. Looking at the case study, Dr. Mary Butler of Minnesota University said that even with edit clicks for tagging of titles and abstract screening, efficiency was increased by about 30%, which is quite significant. Further, 22% of the citations were excluding using machine learning, natural language processing-based inclusion, right? So using automation. And a preliminary evidence map was available upon completion of the first screening of the title and abstract, meaning that by the time that they were done with the screening, they also created some order out of this messy data. So in summary, to improve the efficiency and reduce waste, one needs to look at three elements. One is reduce the learning curve. How do you do that? By creating a familiar user interface, consistent user experience, add some videos and searchable documentation so the user can read and watch on their free time and offer support when they're stuck. You also need to improve the project management tools. So have an agile configuration. So as needs change during the project, it should not be an opinionated system and tell you exactly what to do, but rather you will choose your own path. It should be a collaborative tool. This is a web-based technology. It has collaboration. People can exchange notes, can share information, and also provide user and project analytics so that the project lead will have a fairly good sense, like from a bird's eye view, of what's going inside his project, specifically if they have large team of people or large number of citations. And of course, add automation when possible, like as an example, in our case is deduplication, keywords and key phrases highlights, as we looked at the highlights from population intervention and outcome, add predictions so that it will make the process more efficient, and always think about transparency. So when information on automation is being launched, it's totally transparent to the researcher and they can see what's the logic behind it and agree or disagree with it. And with that, if you are looking for more information, please visit the website at https://picoportal.org, or you can contact me directly, Eitan Agai, which is Agai, EAGAI, @picoportal.org. Thank you very much.